Good day, everyone, and welcome to the first webinar that we're having for this year. This is the Neogen Petrifilm Technical Training 2025. I am June Barnes, and I am the Regional Customer Education Manager for Neogen Asia Pacific. This training is designed for both current and new Petrifilm users who are looking for a refresher, as well as for those who are interested in learning about additional applications or clarifying any questions you may have about the product. Our goal is to help you enhance your testing with Petrifilm plates. Now, for those of you who have not used Petrifilm plates before, we hope that this session will give you a better understanding of the Petrifilm technology, its applications, and the reason why it remains to be the leading ready-to-use plate in the market. This event is, of course, brought to you by Neogen. In addition to Petrifilm plates, our portfolio includes solutions for hygiene and sanitation monitoring, allergen and toxin testing, pathogen detection, and nutritional analysis. When combined with Neogen's genomic services and analytics platform, we provide a comprehensive solution designed to boost efficiency and enhance food safety and quality processes. Our expanded product range enables us to better support you, our dear customers, in safeguarding the world's food supply, from farm to table. Now, in addition to offering solutions that help food manufacturers maintain the highest standards of quality and safety, Neogen is also dedicated to providing quality education and training to support your organization. From webinars to workshops, we offer a wide range of both online and in-person resources and events designed to enhance the skills and expertise of you and your team. Now, building on this, we'd like to invite you to the next webinar, which is happening on February 18 via On24. The topic is Be Serious with Be Serious, where we will delve into why this bacterium is a critical concern in the food industry. We are thrilled to have Dr. Chai Lai Ching of Sunway University, Malaysia, and her very own Scott Egan as speakers. Now, just in case you want to join, simply scan the QR code and complete the registration form. Please make sure to share this QR code as well to your workmates or friends who may benefit from this webinar. Now, for this webinar, we are using the On24 platform. To ensure that you have the best experience, here are a few housekeeping reminders. First, all webinar engagement tools are expandable. You can adjust the size of the slide area or maximize it to full screen. You may find all of the minimized tools at the dock at the bottom of the screen, the one with the yellow box. After the presentation, we'll have the question and answer session. Please submit your questions and comments via the Q&A engagement tool. All you have to do is type in your questions and click submit. Take note that you can submit your questions at any point of the webinar. Another important tool that I want to highlight is the resource list, where you can download the files related to this webinar. So if you're looking the Neogen versions of our instructions for use, or you're looking for instructions in relation to environmental monitoring, the resource list is where you will find the information. We also value your feedback. That's why we're requesting everyone to fill up the short webinar survey towards the end of the webinar. And after attending this, you can download the certificate of achievement, which you can successfully earn by completing at least 1 hour of our webinar today. Now, just in case you want to go back to this presentation, you don't have to worry because this will be made available as on-demand content. An email will be sent to you in 1 or 2 days so that you can access the webinar anytime. Now, for this webinar, we have set 6 learning objectives. We are going to provide you with an overview of Neogen Petrifilm plates, and we're also going to share with you some best practices for using Petrifilm plates effectively. We will also give you the interpretation of plates in a variety of scenarios, as well as calculation of the CFU program from Petrifilm plates. Aside from this, we're also going to provide you with an overview of the Petrifilm rapid plates and a focus on automation with the Petrifilm Plate Reader Advanced or PPRA. I believe all of you are already very excited, so let me take this time to introduce to you our experts for today, which will include Scott Egan and yours truly, June Barnes. Scott Egan is the Regional Technical Service Manager of Neogen Asia Pacific. In this role, Scott leads transformative changes across field technical services, laboratory technical services, and field application scientist teams, collaborating closely with sales, marketing, and global resources. Prior to joining Neogen, Scott gained extensive experience in pathology and industrial microbiology laboratories, where he held roles in quality control, research and development, and process improvement for diagnostic assay manufacturing. He holds a degree in biomedical sciences from the University of Western Sydney. I, on the other hand, bring 20 years of experience in microbiology and food safety. I've served as an educator teaching microbiology courses, as well as managing a microbiology laboratory for a multinational company. I've also served as a professional service in food safety. And in terms of educational background, I hold a Bachelor of Science degree in biology with major in microbiology and a Master's of Science degree in microbiology. Now we will start our discussion now with an overview of the Petrifilm technology, and we'll also take a look at its various applications. As food manufacturers, you know very well that ensuring quality and safety of your products is essential. And that's why microbial testing really plays a very crucial role in achieving this. During microbial testing, you may do enumeration of indicator microorganisms and also detection of significant foodborne microorganisms, like for example, Salmonella or Listeria monocytogenes. When you do your testing, it's possible for you to test for raw materials, some in-process samples, of course, your end products. And lately, more and more of our customers have been testing environmental samples. Now, since your decision largely depends on the results that you are generating from these microbial tests, it's really very important that your laboratory uses validated methods and that your laboratory has thoroughly verified the methods that you have chosen. Now, one product from Neogen that has been widely used globally in the food industry for the past 40 years is Petrifilm plates. And this product will be our main focus for this webinar. So where do you use Neogen Petrifilm plates? Well, they are used for the enumeration of indicator and spoilage microorganisms. And by this time, I'm sure that you're already very familiar with these microorganisms. With indicator microorganisms, it basically gives you an idea on the general condition of your food or the environment where your food is being processed. Some parameters that you test would include coliforms. Of course, you also test for Enterobacteriaceae and aerobic plate counts. For spoilage microorganisms, on the other hand, they are the ones that can cause deterioration of your food and may also lead to unpleasant odors, flavors, or textures. Some of these spoilage microorganisms would include yeast, lactic acid bacteria, among others. So Petrifilm has been widely used for these applications in the food industry. They have been used together with sponges and swabs as part of environmental monitoring. Some of our customers use it a lot for checking on the quality of food because you can quantify the spoilage microorganisms. Some of our customers also use it for shelf life studies. And in terms of the matrices where Petrifilms have been used, it's really very extensive, from meat and poultry to dairy products, fruits and vegetables, ready-to-eat foods, name it. Petrifilm has been widely used for these applications. Now, in terms of the design, Petrifilm plates would consist of three main components, and they are actually reflected on the cross-section of the Petrifilm plates. As you can see, they are made up of films and added with adhesives. Adhesives are the ones which basically attach the nutrients which are necessary for the growth of the microorganisms. They are also added in some cases with selective agents so that you can allow the growth of your target microorganisms. Now, in the top film, aside from the adhesives, you also have there the indicator dyes. And this is very important because they are the ones that allow you to easily see the colonies. And in some of our plates, these indicator dyes allow you to differentiate one type of microorganism from another. For example, in the case of Petrifilm E. coli coliform count plates, coliforms would appear red with gas, while E. coli would appear blue with gas. So that differentiation is made possible because of the addition of indicators in the plates. So very simple design, and yet this has been proven to work for many food products. Now, in terms of the applications of our Petrifilm plates, it's again very extensive. On the left side of your screen, you will see there our standard plates. And you may notice that we're covering already a majority of the indicator tests which are needed in the food industry, from aerobic count to yeast and molds, coliforms, E. coli, lactic acid, Staphylococcus aureus, environmental listeria. We even have a Petrifilm for testing heterotrophic count in water. But we do understand that you want something faster, you want quicker results, and that's what drove us to develop the rapid versions of the Petrifilm plates, as you can see on the right side. Currently, we have for aerobic count, yeast and molds, also for coliforms, and for E. coli and coliforms. Basically, with rapid plates, we are able to cut down the incubation period by half. Just to illustrate, in our standard yeast and mold count plate, incubation will take 5 days. That's the approved incubation time. But for our rapid yeast and mold, we're able to bring down the incubation period to just 2 days, saving companies a lot of time for waiting on the yeast and mold counts. Now, we often receive questions like, are they really working? Will these ready-to-use plates really work? And our proof that they do really work is the extensive validations that we do have. Petrifilm has more than 105 global validations and have been widely used throughout 60 countries, including major countries within Asia Pacific. In terms of the validations, we get them from organizations such as the AOAC and AFNOR, which basically proves to you that the results are equivalent to the FDA BAM and ISO standards respectively. Aside from that, we are also recognized by regulatory agencies such as the American Public Health Association, also by the US Food and Drug Administration, and the US Department of Agriculture. Now, just in case you are interested on the full list of approvals that we have for Petrifilm, do visit our website at www.neogen.com. So that's it for some information about Petrifilm plates. We will now go to one of the core topics that we have, which is on best practices for using Petrifilm plates effectively. But before I go into my discussion, I want to have a poll question first. And I would like to request everyone to participate in this poll question. Which step in using Neogen Petrifilm plates do you find most challenging? And you would therefore benefit from learning best practices for this part. You have several choices, including sample preparation. That's the one where you have dilution and homogenization. The second choice is inoculation, where you plate your diluted sample. Is it incubation, wherein you place your plates inside the incubator and then maintain them at an appropriate time and temperature? Or is it on interpretation, where you identify the growth of the microorganisms and then counting the colonies? Or are you having difficulties calculating for the CFU program? Or you may be an expert, and that's why you don't encounter any challenges in using Petrifilm plates. We'll give you a few seconds. Oh wow, we have 635 participants. I'm very surprised. Thank you very much. We'll give more time for our customers to pick their answers. And again, the reason why we're doing this is because we want to know which part of the test do we need to give more emphasis on, because it's something that you find challenging. And we have the experts, Scott and myself, to provide you with some expert advice on how you're going to resolve them. We are already at 200 mark. Maybe it's time for us 214 mark. So let's now check on the response. Now, based on your feedback, it seemed like you are encountering the most challenge when it comes to interpretation of results. And you don't have to worry, because we have a section for interpretation of results. And it is followed by inoculation. Don't worry, because I will also be covering it as part of my discussion. And the last one, I think, is on sample preparation. There's also a section intended for it. And for the 3.6% who said that you're not encountering any challenge on Petrifilm, thank you. Thank you very much. Okay. So what we will do now is to guide you through the key steps in testing your samples using Petrifilm plates. And for those of you who have already used Petrifilm, you know that there are three main steps in testing: inoculate, incubate, and interpret. But of course, prior to inoculation, you have to prepare your sample. And after interpretation, you have to count the colonies and then calculate for the CFU program, so that you can check if you are within specifications or not. We'll go through each of these steps, starting with sample prep. If you're doing any microbial tests, you know very well that this is a main step in your testing. This is very crucial in microbial testing, because this is the reality. The quality of your results directly depends on the quality of your sample. No matter how good your method is, if you start with a poor sample, you cannot expect a miracle wherein you will have good results. So it's very important that the sample that you are taking is a representation, a good representation of the bulk product. And you also want to make sure that it's collected by someone trained and authorized, so that you will prevent contamination of your sample. Now, once you've already collected your sample, it's also very important for you to understand your sample. And usually you need to ask, is my sample a high microbial background sample, or is it a low microbial background sample? Because if you have a high microbial background sample, like for example, raw ground meat or environmental samples, where it would contain high bacterial loads, and if you don't process them properly when you do your plating, you will see growth similar to the plates that you can see on the right side of your screen. It's very difficult for you to isolate individual colonies, and because of that, you cannot accurately quantify the bacteria. So the consequence of this is that you're basically wasting your valuable time, and you can potentially compromise the accuracy of your results. Now, the other issue of not processing your samples well is clumping may happen. On the left side, as you can see, there's very good separation of your cells. So when you plate this, if you have 6 cells, you'll be able to generate 6 colonies, which is a very good representation of the original number of microorganisms in your sample. The problem is, if the number is way too high, there's a tendency for the cells to clump. So in this case, you should be forming more colonies, but because they have clumped together, basically you end up with 6 colonies. which is an underestimation of the actual count of microorganisms in your sample. So to avoid this, understanding your sample is very important so that you can know the extent of dilution that you need to make. Basically, your main goal in doing serial dilution is to thin out the microbial population so that it's possible for you to form distinct and countable colonies on the plate. But of course, when you're doing your dilution, it's crucial that you use the appropriate diluent based on the type of sample that you're working on. So for Petrifilm, what are our recommendations? So on screen right now, you can see some buffers, some diluents that are suitable for use with Petrifilm plates. In general, these diluents would contain salts or phosphates, which are really necessary to prevent osmotic stress on the cells so that you're able to maintain their integrity. It's also very important that there's buffering capacity, especially with foods that can be quite acidic. And of course, during the growth, it can be quite acidic. So you want to neutralize that because low pH may affect the survival of microorganisms. And lastly, you want to have some peptones in order to support the stressed cells. Again, these are some of the recommended diluents for Petrifilm, but it's always important for you to refer to the product instructions for each specific time that you are using so that you're able to prevent any errors during testing. How about in the case of environmental samples? Now, the requirement is very different. You need to have a neutralizing solution for your sample collection tool. The reason why you need to have a neutralizing solution is because there may be residual sanitizers from the sample, and you want to neutralize that so that they will not inhibit or kill the microorganisms that you have collected. Now, there are several neutralizing solutions that you can find in the market. So which one do you choose? So I'll be giving to you two recommendations. First, you want to make sure that it is effective in neutralizing the sanitizer that you are using in your facility, because the reality is not all neutralizing solutions work for all sanitizers. So that's the first requirement. Second, you want to make sure that it is also compatible with the method that you are using. So in the case of Petrifilm plates, we have two recommendations. First is lithium broth, which you can find in our quick swab. And the other one is the wide spectrum neutralizer, which is present in our environmental scrap sampler. Okay, so please make sure that you choose the right neutralizer for use with Petrifilm. Just in case you have any sample collection tools with DE neutralizing broth or neutralizing buffer, please refrain from using them because the presence of thiosulfates in this neutralizing solution can inhibit the growth of microorganisms in Petrifilm plates. Now, since we're already talking about environmental monitoring, did you know that Petrifilm plates can be used as part of your environmental monitoring program? You can use it alongside your favorite sample collection tool. In the picture that you can see on the left side, it's the Neogen Quick Swab, which is used for sampling. But aside from that, you can also use it for surface contact, which is very ideal for equipment with flat surfaces, and also for air sampling. For air sampling, most of our customers would use our Petrifilm aerobic count plate and our Petrifilm yeast and mold count plate, and open it up and keep it open for 15 minutes of exposure. Now, for the last two applications, I just want to remind all of our customers that it's important for you to hydrate first the Petrifilm with 1 ml of your sterile diluent, and please keep them closed for at least 1 hour before use. Just in case you want detailed information on how you can use Petrifilm plates for environmental monitoring, they are available in our resource list. So you can download the information later on. So you already have your sample. It's now time for you to process it. And this is now where you will have your initial preparation. um, in many cases, our customers will use a 1:10 dilution. So the ones that you're seeing on the screen right now, 1 gram to 9 meals, 10 grams to 90 meals, 11 grams to 99 meals, all of them will give you an initial 1:10 dilution. The same is true for 25 grams to 2.5 or 50 grams to 450 meals of your diluent. Now, some of our customers, they will already stop at 1:10. But as I mentioned earlier, again, you need to understand your sample so that you can know the extent of your dilution. So what will be the factors determining how much dilution you need to make? We're giving you 4 important factors. The first one is, again, the level of your background flora. In general, the more microorganisms you have in your sample, the more dilutions you need to make. Okay. Second would be the method being used. So for instance, if you're using ISO methods, generally they would suggest 10 grams of sample. But if you're following FDA BAM standards, they generally recommend using 11 grams of sample. Third would be your regulatory requirements and the validated methods. So it's always important for you to have a copy of this method so that you know exactly what your recommendations are in terms of your sample preparation. And lastly, always consider the properties of your sample. For example, you're working on very thick samples or samples that are deeply colored, or maybe samples with inherent inhibitory properties because it contains a lot of spices. In many cases, doing a 1:10 dilution will not be enough because the consistency of the sample may still be too thick, and therefore it's very difficult for you to spread it. In some cases, it may not be enough to dilute the color intensity of your sample. And in some cases, we have seen that doing a 1:10 dilution for spices is not enough because the concentration of inhibitory substances are still very high. So in such cases, you need to do further dilutions in order for you to get more accurate results. Now, in terms of your dilution, there's actually an example provided here that the sample is cheese, and the plate that was used is Petrifilm aerobic count plate. And you just need to check the instructions for use for you to know the recommended counting range, which in this case is 25 to 250. So as you can see, the sample was diluted up to 10 to the -4. And after incubation, you can see that there are different counts obtained. And in order for you to choose the right dilution for calculation, you want to make sure that the count provided is within the counting range. So in this case, the choice is 10 to the -2 or 1:100 because the count obtained, which is 143, is within 25 to 250. So it's now possible for you to identify the extent of your dilution if you're repeatedly testing the same sample. For example, in this cheese sample, if you know that your preferred countable range will be obtained at 1:100 all the time, so that means that in your succeeding test, you just need to prepare dilutions up to this level and then just plate it. This is something that you can do in the other samples that you may have in your laboratory. So once you've already mixed your sample with the appropriate diluent, it's now time for you to blend it for about 2 minutes. You can make use of a stomacher or a blender. If you don't have this equipment, you can always depend on your hand mixing to prepare your sample. Now, a very important reminder, please don't keep your diluted sample for a very long time. Take note of your holding time. You want the sample plated in less than 20 minutes because there's a very high probability that the number of microorganisms will increase later on. Again, our goal here is to get accurate counts, so please plate your samples immediately after dilution. Now, for some of the samples that you may have, it's possible that food particles may be taken out or pipetted out and plated onto Petrifilm plates. So it's very important that if you have samples like this, you know exactly how you can prevent your food particles from being plated on Petrifilm plates. There are 6 recommendations shown now on your screen, but based on my personal experience, 3 of them work the best. You can do further dilutions, you can use filter bags, or you can let your sample settle for about a minute after homogenization before taking out 1 meal of your sample for plating. Again, the reason why we are concerned about this is because you want to reduce the risk of your food particles interfering with your results. So for those of you who are not familiar with filter bags, this is basically the design of a filter bag. You have a filter in between. So on one side, that's where you will place your sample. Afterwards, you can pour in your diluent and then subject it to blending or homogenization. Now, once you're ready to plate, you open up the clean side or the other side of your filter, take your sample from there so that you will not be able to take food particles anymore. Does it work? Yes, it does work. And here is an example. In this slide, the sample that was plated was strawberry yogurt. And on the left side, filter bag was not used. So as you can see, there were bits and pieces of strawberry that were plated. And for some analysts, they may confuse these as colonies, and that may lead to overestimation of count after incubation. But as you can see on the right side, when a filter bag was used, it appears a lot cleaner. So when you do your incubation and colonies start growing, you are sure that what grew are really colonies of your target microorganisms. Now, the other recommendation that we had earlier was doing further dilution. Does it work? Well, it does. And this is our proof that it really does work. For this slide, the sample was green tea. And as you can see, it was diluted up to 10 to the minus 3. And as you can see, as you go from 10 to the minus 1 to 10 to the minus 3, the amount of food particles is significantly reduced. Again, this is something very useful so that you will have better interpretation of your results. And lastly, this is in the case of paprika. Okay, so paprika, it's very fine. And because of this, when they use filter bags, it would pass through the filter. However, they cannot do a lot of dilution because the microbial count is expected not to be that high. So in this case, we customize the dilution. So instead of using the usual 1:10, we recommended that they use the sample 1:20. And it did work. As you can see on the left side, where they plated a 1:10 dilution of paprika spice, the color is quite intense because of the paprika sample. And you can see that the colonies are too close to each other. But on the right side, the color is significantly reduced. And as you can see, better separation of colonies. Therefore, interpretation and counting was a lot easier. Okay, so you can always customize your dilution. Again, the key here is understanding the properties of your sample. Now, the other question that we often receive is, do I need to adjust the pH of my sample? Okay, well, it really depends. But in general, you know very well, microorganisms would prefer a neutral pH. So if you have very acidic samples or very alkaline samples, you really need to bring down the pH to a level based on the tolerance of your Petrifilm plate. So in some Petrifilm plates, the tolerance can be wider from 5 to 8, but in some plates, it's too narrow, 6.5 to 7.5. So always consult the instructions for use regarding pH of your sample. So once you prepare your 1:10 dilution, again, check the pH tolerance of your plate. And if it's too acidic, you can put one normal sodium hydroxide, and if it's too alkaline, you can put one normal hydrochloric acid to make the adjustments. You can always use a pH meter or litmus paper strip to check if you're already close to the target pH. What you can do is, monitor the amount that you're adding for that specific type of sample so that you can standardize your process in the future. So once the sample is prepared, it's now time for you to inoculate. So let's now look into this. Very important reminder. Prior to inoculation, please make sure to bring your plates to room temperature. Never use Petrifilm plates straight from the refrigerator for new packs or straight from the freezer from open pouches. Let them rest for a while until they are at room temperature. Don't forget the label. Always follow your laboratory protocol on labeling. And during testing, you know this very well. Please make sure that you apply aseptic techniques to prevent contamination. Now, in terms of plating, you have to consider the design of the plate that you are using. There are two designs. One is the one without foam dam, just like in the Petrifilm aerobic count plate. And the other design that we have comes with a foam dam, such as in the case of Petrifilm E. coli coliform count plate. This distinction requires different techniques during the plating process. Okay? So this is the one without foam dam. And I've highlighted in red box the key differences. If you will notice, after inoculation of 1 meal of your sample, your top film, you just need to drop it. And after dropping, you spread the inoculum by making use of the ridge side of your spreader. In the case of Petrifilm with foam barrier, such as in the case of Petrifilm E. coli coliform count plate, you cannot drop the top film. Instead, you roll it so that you avoid entrapping air bubbles. And when you're ready to spread, please use the flat side of your spreader. Very important reminder, especially for those new users who are joining us for today. Now, did you know that we have 5 different spreaders? And please make sure that if you are using any of the plates listed here, please make sure that you have the correct spreader to use. Now, just as a reminder, whenever you are spreading your sample, be gentle. If you press it too much, there's a tendency for your sample to leak. So the idea here is to let the weight of the spreader do most of the work. Don't press too much. And also, don't forget to wait for a minute so that the media will have the opportunity to gel up before you place your samples inside the incubator. Okay? Now, I do understand that some customers would say that using the spreader is an extra step in using Petrifilm plates. But did you know that using the spreader actually works to your advantage? It may be an additional step, but it is something that is very important for you to do so that you can have a better distribution of the cells. By doing that, you're able to separate the cells so that you can form now more separated and distinct colonies. Again, prior to using the spreader, please make sure that the analysts have been trained. Please make sure that you are using the appropriate spreader for the Petrifilm plate that you are using. And don't forget 1 minute of gelling before you place the plates inside your incubator. Okay? Spreader is very important. Now, we also receive questions if it's necessary for laboratories to use controls. Now, I just want to inform all of our customers that prior to release in the market, extensive testing of our plates have been done to check on conformance to our standards. And this was done in our facility. So you are assured that our Petrifilm really performs prior to reaching your laboratory. However, we do understand that for your laboratory, if you really want to practice good laboratory practices, it's always best to use positive and negative control. For positive control, make sure that you use a microorganism that will really grow on the plate. And for your negative control, use a known microorganism that will not grow in your plate. It's also good to have a negative sterility control. Just place 1 ml of your media to check on sterility. Now, in terms of the shelf life, please make sure that you use the plate within the shelf life indicated on the pouch. To maintain integrity of your plates, please make sure that they are stored properly. For your unopened pouches, as soon as they reach your laboratory, refrigerate them or freeze them. Once you open and you're about to store them after use, remove as much air, seal them with tape, and then place them at room temperature or freeze them. Now, if you use storage at room temperature for your open plates, please don't forget to write the use by date because it's only good for 30 days. If you want to maximize, because you're not testing that many plates, you can always freeze them. In such case, it will be good up to the end of the shelf life of your product. Now, for your unopened pouches, it's good up to 18 months from the date of manufacture. And you can find the date of manufacture per pouch and also on the box. The format is year, month, and date. Okay. Now that we have completed the first two steps, it's now time for us to incubation. Easy part. All you have to do is to place your plates inside the incubator with the proper temperature and maintain there up to a certain period of time. Now, in doing this, please make sure that it is clear which validated protocol that you are using, because different validated protocols would have different recommendations. Also check on the instructions for use for this. So just to give you an idea what I'm referring to, here is the recommended incubation temperature and time for Petrifilm aerobic count. If you follow AOAC OMA, you can see here that for all other foods except dairy, the recommended temperature is 35 degrees Celsius plus minus 1. Incubation time, 48 plus minus 3 hours. But if you're following NordVal, you will see here that for all other foods, the recommended temperature is 30 degrees Celsius for 2 days. But both are okay, both are validated methods. Now, if you're going to compare that now with our rapid aerobic count plate, you will see here that for AOAC OMA, for all foods except dairy, you can see it's the same recommended temperature, 35 degrees Celsius. However, the incubation time is much shorter, only 24 hours, plus minus 2 hours. So that's the approved incubation time for Neogen Petrifilm Rapid Aerobic Count Plate based on AOAC OMA. In the case of our Petrifilm yeast and mold count plate, we have validation for AOAC OMA. And as you can see, the incubation time is 5 days at 20 to 25 degrees Celsius. But if we're using our rapid yeast and mold count plate, it has validation for AOAC OMA, 2 recommended temperatures, either 25 or 28, and the incubation time is just 2 days up to 60 hours. Okay, so please always go back to the validated method so that you know exactly the incubation time and temperature needed for the optimal growth of your target microorganisms. Now, for your incubation of Petrifilm plates, it's possible for you to do stocking In most cases, 20 plates high is a recommendation, but there are exceptions to this, such as in the case of our Petrifilm Rapid Aerobic Count plate. For all other foods, you can stock the plates up to 40. Similar case in Petrifilm Rapid Yeast and Mold Count plate. Just a reminder, when you're stocking plates, make sure that they are the same with each other. And don't just rely on the gauge of your incubator. Best practice is for you to have a calibrated thermometer placed inside your incubator, and that is what you monitor, just for you to know the actual temperature inside. And with this, we have already completed the first.
Thank you everyone for joining us today. My name is Scott Egan. I am the Technical Service Manager for the Asia Pacific region. And I'm going to be presenting for the second half of this webinar today. Today, I'm going to begin by talking about interpretation of Neogen Petrifilm plates. Interpreting colonies on Petrifilm plates is crucial for obtaining accurate results, and to assist with this, Neogen provides interpretation guides for each type of Petrifilm plate. These guides can be accessed on the Neogen website, and we've also included them in the resource tab for this webinar, where you can download them. For this webinar, we will just focus on certain scenarios where interpretation may be challenging, such as in the case of TNTC or too numerous to count plates. All of our Neogen Petrifilm plates have an upper countable range. Plates which have a number of colonies above that range are considered as too numerous to count, or TNTC. Often we can see several hundred colonies on the plate, indicating that the colony count is TNTC. On occasion, colonies may not be visible, and you'll need to look for characteristics of the plate which indicate that the plate is actually TNTC. There are four main characteristics we're going to look for to determine if a plate is TNTC. Firstly, it's a change in plate color. Secondly, a dark ring around the edge of the plate. Thirdly, excess gas bubbles. Fourthly, many small pinprint colonies or very faint colonies. These are all things that you should observe on your plate to be able to determine if a plate is actually TNTC. Here we can see three examples in which the color of the plate has changed, indicating a TNTC result. For each example, the original plate color is on the left, and the TNTC plate, resulting in a background media color change, is on the right. The next characteristic of TNTC plates is gassing of the plates. This is mainly observed on plates that look for gas formation associated with a colony. As you can see, the coliform and lactic acid bacteria plates on the left and center are completely gassed over, and no colonies can be observed. This is not due to poor plating technique, but rather an extremely high level of gas producers present in the sample. The E. coli coliform plate on the right has so much gas production occurring with each colony that they are starting to form channels. A dilution in this case will aid in interpretation. All these plates should be recorded as TNTC, and the sample should be further diluted until counts within the acceptable countable range are obtained. The last characteristic of a TNTC result is many small faint pinpoint colonies. This example shows ground beef plated at both 1 in 10 and 1 in 1,000 dilution. In the image on the left, there are innumerable E. coli and coliform organisms on the 1 in 10 dilution. Notice how underdeveloped and pinpoint the colonies are. This is due to the amount of competition for nutrients from the high concentration of microorganisms. Also notice how difficult it is to see the gas production. This is again due to the level of competition on the plate. When the sample is diluted to 1 in 1,000, as shown in the image on the right, you can start to see these nice, bold, distinguishable E. coli colonies with large gas bubbles associated with each individual colony. For accurate counts that are easy to interpret, it's important to dilute the samples until the counts are within the preferred countable range of the plate. Okay, so now we're going to go to a live poll. So you'll see the question on the screen now. So the questions are based on the interpretation of the plate you see. So what would you say this plate is? This plate contains 1,000 CFU per gram. This plate is TNTC due to the ring of colonies surrounding the growth area, background media color change and pinpoint colonies? Or would you say this is a no-growth plate and it's likely due to food particles? So now the poll is live. So please submit your answers and we'll see what everyone thinks here. The results starting to come through now. Okay, so almost 700 people online and about 10% have answered. So give it a few more moments. Getting everyone online, we've just got this live poll going. So based on the plate you saw before, would you say this plate contains about 1,000 CFU per gram? Is it too numerous to count due to the ring of colonies surrounding the growth area, background media color change and pinpoint colonies? Or would you say this is no growth and it's likely due to food particles? Yes, about a third of people have answered so far. Let's see if we can get to 50%, and we'll see what everyone thinks. Okay, let's have a look now. So 8.9% or 9% said this plate contains about 1,000 CFU per gram. The vast majority, 84%, said it's too numerous to count, and about 7% said this is likely to be due to food particles. Actually, the correct answer is too numerous to count. So some of the key points we're looking for there is that ring around the edge of the plate and very, very, very small pinpoint colonies. So in this case, we need to call it too numerous to count and use a further dilution so we can actually get the sample down into the countable range. Another common question we receive is on liquefiers. On the Neogen Petrifilm aerobic count plate, you may experience colonies which are known as liquefiers. Liquefiers are bacteria, typically bacillus, which produce enzymes that can liquefy the gel as they grow. This allows the organism and their products to diffuse within the plate and can cause surrounding colonies to merge together. This phenomenon is not specific to Neogen Petrifilm plates, and a similar effect also occurs on traditional agar methods in the form of spreader colonies. In this example, the liquefiers only impact a small region of the plate. You can perform an estimated count by averaging a few unaffected squares and multiplying it by the surface area of the plate. For example, in the highlighted squares, 52 colonies were counted. 52 divided by 4 gives the average of 13 CFU per square, and multiplying that by the 20 square centimeters of the plate gives a total estimate of 260 CFU. When using the Neogen Petrifilm aerobic count plate, here are several ways to reduce the presence of liquefiers. Firstly, evaluate the Neogen Petrifilm rapid aerobic count plate. This plate has a proprietary technology that prevents the liquefying species from taking over. It also has a shorter time to result, so they have less time to produce a liquefying effect. Secondly, try incubating the aerobic count plate in shorter stacks. You can try using the spreader from the Neogen Petrifilm yeast and mold count plate. This will spread the sample further to help prevent the liquefiers from touching other colonies. You can also try incubating at a lower temperature of 30 or 32 degrees Celsius. This will help slow the growth of the liquefiers. You can perform a further dilution, which will also reduce the number of liquefiers so they don't take over the entire plate. Or finally, you could perform an estimated count around the liquefied area, just like the example that I showed earlier. Of course, before making any of these changes, make sure to check your company's internal SOPs and confirm the modifications have been verified. At this point, let's focus on interpreting the results from the Neogen Petrifilm Staff Express system. On this plate, you may observe red-violet, blue, green, or black colonies. So what should you do when you encounter these different colony types? Let's start by understanding what these colony types may be. Red-violet colonies may be Staph aureus, Staph hyacus, or Staph intermedius. Blue-green colonies are not Staph aureus. They may be Enterococci or Bacillus species. Black colonies may or not be S. aureus. If they're S. aureus, they may have been stressed. Otherwise, they're typically Staph epidermidis or other coagulase negative staphylococci. Now that we know a little more about the various colony colours, let's consider their interpretation and the use of the conformation disc. As per the IFU, if no colonies or only red-violet colonies are present after 24 hours, count the colonies as S. aureus, S. hyacus, or S. intermedius. Use of the conformation disc is not necessary in this case. If a conformation test is required, or if any other colours besides red-violet are present, the conformation disc should be used. Now looking at some possible scenarios with the Petrifilm Staph Express system. In both examples shown here, only red-violet colonies are present. In this case, all colonies are enumerated. The example on the left will be reported as 5 CFU, and the example on the right is reported as 16 CFU. Since there are no other colony types present, the use of the conformation disc in this case is not required. In this second example, the plate is showing only black colonies. Since we do not know if these are stressed S. aureus or other organisms, the conformation disc should be used. In this case, several colonies developed pink zones following the use of the conformation disc, and as a result, we report this as 11 CFU. And in this final example, the plate is showing a mix of red-violet, blue-green, and black colonies. Again, since we cannot be sure of the identity of all these colony types, the conformation disc should be used. In this case, after using the conformation disc, several colonies have developed a pink zone, and the result is therefore reported as 5 CFU. Now I want to move on and look at the Petrifilm yeast and mold count plates. Both types of Petrifilm yeast and mold count plate utilize a phosphatase indicator dye. All living cells contain phosphatase. Therefore, natural phosphatase in samples can cause the indicator to react. Two types of colour reactions are sometimes seen, either a uniform blue background colour or intense blue spots. Figure 7 shows an example of the uniform blue background colour, and Figure 8 shows intense blue spots, which are often seen with spices or other types of granulated products. Here's an example of a spice sample plated at a 1 in 10 dilution on the Petrifilm rapid yeast and mold count plate. Notice the light blue background colour change. These plates were also checked during the first 8 hours of incubation, where the colour reaction was observed, confirming that it was indeed a phosphatase reaction versus TNTC. This is seen every time this sample type is plated onto Petrifilm yeast and mold count plates, allowing technicians to familiarise themselves with the reaction. The yeast and mold colonies are still visible as shown in the image on the right, despite the phosphatase reaction. To reduce a phosphatase reaction, you can follow one or more of these techniques. Firstly, you can dilute the sample further to minimise the blue background colour or reduce the number of intense blue spots. You can mix the sample, then let particles settle, then draw the sample from the centre portion of the sample container or use filtered homogenizer bags to avoid plating of large particles. Finally, you can try observing the plates within 24 hours of incubation and make note of any colour change to aid in the final interpretation of the plate. So now that we've reviewed how to interpret results from various plates, let's cover how results are calculated and reported when using Neogen Petrifilm plates. In this section of the webinar, we will cover calculating results from the following scenarios: 1 plate from 1 dilution, 2 plates from 1 dilution, 2 plates from 2 different dilutions, and plates with no growth. The first example we will look at is 1 plate from 1 dilution. This is often performed in routine testing. The general equation is the colony count multiplied by the dilution factor and divided by the volume plated. You can also put the dilution on the bottom half of the equation, and in that case the value is decimalized, as you see in the example here. In this particular example, we have chosen chocolate chip ice cream plated at a 1 in 100 dilution, and 18 colonies were observed. So 18 colonies multiplied by 100, the dilution, divided by 1 ml, which was plated, gives us 1800 CFU per gram as our result. Now the second reported scenario we're going to look at is 2 plates from 1 dilution. This is often referred to as plating in duplicate. In this case, the general equation is to multiply the average number of colonies by the dilution factor and then divide by the volume plated for each plate. In this example, determine the average number of colonies by adding 11 colonies from plate A plus 15 colonies from plate B, then divided by 2. Multiply the dilution factor, which is 10, to get 130 CFU, and divide by the volume plated, which is 1 ml, meaning the result remains 130 CFU per gram or ml. The third reporting scenario we're going to look at includes 2 plates from 2 dilutions, and this becomes a little more complicated. The calculation is performed when there are counts at 2 different dilutions that are both within the acceptable counting range. The general equation is total number of colonies added from all plates divided by the sum of the dilution factors multiplied by the volume plated per dilution. For example, this sample was plated on a rapid yeast and mold Petrifilm at 1 in 10 and 1 in 100. Plate A contains 150 colonies and plate B contains 25 colonies. Both counts are within the preferred countable range of less than or equal to 150 CFU. In this calculation, we add the 150 colonies plus 25 to get the total, which is then divided by the sum of the dilutions, which is 0.1 plus 0.01, multiplied by the volume plated, which is 1 ml, to give a total of 1600 CFU rounded according to the significant figures. So the final reporting scenario we're going to look at is plates that have no growth. We never report 0 CFU with Neogen Petrifilm plates. If no growth is observed, we report based on the sensitivity of the test. The general equation for sensitivity is dilution divided by the volume plated. In this example, a sample was plated at a 1 in 10 dilution onto a Neogen Petrifilm Enterobacteriaceae count plate, and no colonies were observed. Therefore, the sensitivity equals the dilution, which is 10, divided by the volume plated, which was 1 ml, so 10 divided by 1 equals 10. So the reported value is less than 10 CFU per ml or gram. For the next section of this webinar, we will be having a look at the rapid Petrifilm plate portfolio, discussing some of the advantages of using these plates, and how they can increase operational and testing efficiencies. The Petrifilm rapid portfolio consists of rapid versions of tests, including our rapid aerobic, rapid coliform, rapid E. coli coliform, and rapid yeast and mold count plate. For this webinar, we're going to be focused on 2 of these plates, the rapid aerobic count, or RAC, and the rapid yeast and mold count plate, or RYM. The Petrifilm rapid plates were developed with efficiency and ease of use at their core. The benefits of Petrifilm rapid plates include up to 50% faster time to result, allowing for quick decision making and shortened product hold times, compatibility with a wider range of pH ranges due to the built-in buffering capacity. This streamlines the sample preparation process and reduces time spent pH checking or adjusting. All rapid plates are compatible with the PPRA to further increase productivity. We also have technology to control microbes that spread or cause liquefaction to improve interpretation and reduce the number of dilutions needed for challenging samples. The chromogenic indicators facilitate colony counting and interpretation and increase consistency between operators. We also have larger stack heights for some of these plates, which reduce the amount of incubator space required. The first plate I want to cover in more detail is the Petrifilm rapid aerobic count plate. Here you can see that the sample pH range must be greater than 5 before plating. This represents a broader pH range for prepared samples compared to the traditional aerobic count plate. Another key feature of the Neogen Petrifilm Rapid Aerobic Count Plate is its AOAC-validated 24-hour incubation time for all food and environmental samples, except for dairy powders, which have an incubation time of 48 hours. On the Neogen Petrifilm RAC plate, the dual sensing indicator technology causes colonies to be either red or blue. Sometimes you may even see both. With this technology, it's not unusual to ask if the difference in colony color means anything about the type of organism, or what does it mean if you see a purple colony or some other color. So as the microorganisms grow on the plate, they will utilize one or more of the indicators in the plate and the color will develop. It's impossible for us to predict which indicator an organism will use, as it depends on which metabolic pathway the organism uses, and this can be influenced by nutrients or energy sources in the sample. For example, an E. coli strain may produce a blue colony on the RAC plate on one occasion, but when the same organism is added to a different food type, it may produce a red colony. For this reason, we can't rely on the different colors to tell us any specific information about what type of organism it may be. As I mentioned earlier, sometimes an organism may even use both indicators. So it may start by using the red indicator in the early phases of its growth, and then switch to the blue indicator. This can cause a colony color like we see in the middle picture, where it's more of a purple color. Or in the image on the right, in the second circled colony, where the center is red and the outer ring of the colony is blue. Regardless, all colonies should be counted regardless of the color, size, or intensity. Another important innovation with the rapid aerobic count plate is the ability to minimize the effect of liquefier organisms. Here's an example of liquefiers plated on the rapid aerobic count plate. This is a salad dressing plated at 1 in 10, 1 in 100, and a 1 in 1000 dilution. As you can see at the 1 in 10 dilution, they completely liquefied the entire plate, making interpretation impossible. When diluted, you can begin to see the individual colonies. Now, let's look at the same sample plated on the Neogen Petrifilm Rapid Aerobic Count plate to see the difference. As shown here, it's much easier to interpret each colony even at the lowest dilution. The proprietary technology in this plate prevents the liquefiers from taking over and can actually perform counts on all of these solutions. So now we will look at the Neogen Petrifilm Rapid Yeast and Mold Count plate. This plate provides a total yeast and mold count within 48 to 72 hours for a broad range of foods, animal feeds, and environmental samples. This represents a decrease in overall time to result by a factor of 2 to 3 days when compared to traditional methods. These time savings can lead to drastic operational efficiency improvements when testing for these typically slow-growing organisms. To differentiate yeast and molds on the Petrifilm Rapid Yeast and Mold Count plate, look for the following characteristics. Yeast will be small colonies with defined edges. They will have a uniform color, which is often pink to tan or blue to green. The colonies will also appear three-dimensional or raised from the surface of the plate. On the other hand, molds are typically large with diffused edges, a dark center, and a flat appearance. The color is most often blue to green, but it can vary and may even take on the natural pigment color of the mold itself. These examples here show how further dilution can reduce the number of colonies to make it much easier to interpret. So going from 1 in 10 dilution, where our plate is too numerous to count, through to a 1 in a million dilution, we have very few colonies present. In this final section of this training webinar, we will explore how automation can further enhance operational efficiency and improve testing workflows using Petrifilm plates. Over the last 40 years, the use of Petrifilm plates has increased laboratory productivity since they require less preparation time while maintaining the same level of accuracy. Often these methods have shorter incubation times due to the development of optimal growth media, environments, and advances in media formulation and indicator technology. but we can do more to further increase productivity by helping analysts improve interpretation and data collection following the incubation of the plates. Traditionally, after incubation, columns are manually counted on the benchtop or using a light box. As many of you might have experienced, manually counting can be a time-consuming and tedious task that can lead to unnecessary strain on the eyes. Additionally, plates that contain more than a few colonies can take a considerable amount of time. For instance, in a study that was conducted by multiple third-party labs, it was shown that a single stack of 25 Petrifilm aerobic count plates containing high numbers of colonies could take up to 30 to 45 minutes to count. And that's just the first step in the process. After obtaining the count, it must be recorded, it may need further calculations, and then likely needs to be transferred to a digital file format or to a LIMS system. Automated enumeration can increase productivity in a single step by counting, recording, calculating, and transferring results in moments. This can mean a reduction of up to 94% of the time taken achieved with a sample of Neogen Petrifilm aerobic count plates with the high counts described above. To meet these improved productivity goals, Neogen developed the Petrifilm Plate Reader Advanced, or PPRA. Using this automation technology, it takes less than 6 seconds from plate insertion to reading. This rapid processing speed allows a single technician to process up to 900 plates per hour, a significant difference from counting manually. In addition, the PPRA also enhances proficiency. With onboard fixed artificial intelligence networks, we train the technology to be used on a wide assortment of food and test types, including some of those more challenging to count, like the Petrifilm Stacked Express plate. Finally, the PPR can help labs really focus on being proactive when it comes to meeting food safety and quality objectives. Collecting data and being able to use the information collected can help technicians discover actionable insights before an issue occurs. In the example shown here, we can see how the PPRA marks the colonies and differentiates their types. In this example using a rapid E. coli coliform plate, red colonies without gas, red colonies with gas, and blue colonies were all differentiated and marked differently. Within 6 seconds, both raw and calculated results are displayed for review by the analyst. Now that we have covered the testing itself and the way to collect the data or results, the question that needs to be asked is what next? We may have the information that allows us to release the product, but is that all we can do with the information? Collecting data over time in a software platform can give you the information needed to drive process improvements, among other things. However, sifting through thousands of results is not simple or efficient if you're trying to identify a single trend or abnormality in the data. That is where the PPRA's included software comes in. It allows seamless data flow from the collection of the results all the way through to a predefined chart or graph that can immediately give users a visual cue if there are any abnormalities that may require corrective action or a process change. Within the software, there are a variety of customizable ways in which you can visualize your data, such as by area, type, or time. This example shows how we can analyze results grouped by production line and we see a clear difference with line 2, allowing us to investigate further and resolve issues faster. Finally, in this example, we will see results for lactic acid bacteria testing from different types of objects, and in this case, the high levels found on the seal can help us locate the source of this common spoilage organism. So in summary, use of the data obtained using Petrifilm plates can allow us to extract more insights and greater value from our testing when looking at individual results in isolation. So that concludes all I have for you today. I hope you found this presentation interesting and useful, and I'll now hand it back over to June, and we'll soon be going into our live Q&A session. So thank you again for your time.